Hi all, in this video we're going to look at how to integrate hyperbolic functions, and then we have those three that we're going to work out. That is going to be 4g, h, and I. So let's start with g there. So in g we have cos theta, sin theta, plus cos theta. So how do we integrate this with respect to theta? Okay, so as usual, if you have tried these questions as I had asked in the previous video, let me know what you found, and you can just also compare with what I am going to find using my approach. Yeah, let's see if your approach is different. Let's compare notes. Let's see how you worked it out. I'd love to see that. But let's dive right into the problem. So to integrate this, in my approach, I decide to relate these to what they are in terms of exponent. We know to say cos is equal to e to the theta plus e to the minus theta. This is going to be over 2. And if you are dealing with hyperbolic sign, this will be equal to e to the theta, but now you have minus there, e to the minus theta over 2. When I perform the substitution, what do I get? So in place of cos, we're going to have e to the theta plus e to the minus theta over 2 divided by, in the denominator, we'll have hyperbolic sign first, which is e to the theta minus e to the minus theta over 2, then plus e to the theta plus e to the minus theta over 2 d theta. So here the over 2 there is present on all the functions there, so it can be cancelled out, so that in the numerator we now just have e to the theta plus e to the minus theta divided by e to the theta minus e to the minus theta, and then plus this. From here, you observe that this expression repeats there, so it will subtract out, leaving our expression as e to the theta plus e to the minus theta divided by e to the theta plus e to the theta d theta. At this point, you can add in the denominator over 2 e to the theta there, and then the 2 can be factored out in the denominator, leaving us, I'll separate the two functions. One will be e to the theta over e to the theta, and the second one will be e to the minus theta over e to the theta d theta. The first part reduces to just 1, while the second part, take this up, or since you are dividing, subtract the powers, which implies that you have e to the minus 2 theta d theta. At this point, we can now integrate this. The first part, when we integrate, that will just be theta. The second part, when you integrate, you're going to have the minus, making this a negative. The 2 comes here, e to the minus 2 theta. Since you're done integrating, plus that constant of integration. So that our solution will be 1 over 2 theta minus 1 over 4 e to the minus 2 theta plus c. So this is the solution I am finding. Let me know if you were able to find a suitable trig identity for hyperbolic functions that maybe you used directly without using exponents. That is, if you went that way. In the next problem, we now want to see the integral of this. Okay, so this is what we want to look at. Now, most trig identities for hyperbolic functions, they're similar to ordinary trig identities. So you see even here, the technique that we use to integrate this will be similar to the methods that we would use for ordinary trig functions. So how do we approach this? The first thing that we'll do here is to isolate one of the sec terms there. So this will be sec to the power 4, 5x, and then here we'll have the isolated one, and then here we have, I think that was hyperbolic tan. Let me just confirm that. Yes, that is hyperbolic tan there. Okay, so we do have an h here, an h there, 5x dx. So the trick here is to observe that here the argument is the same, 5x for each function. From here, the next thing I would do is I want to let u be equal to such 5x. Why this? Because I know to say the derivative of u with respect to x will be equal to the 5x differentiated multiplied here. And then now when we multiply when you differentiate the such, you know to say the derivative will be negative. This with the tanish 5x there. So this is why we wanted to isolate one of these terms, because we know to say it's going to cancel with what will show up there. From here, when we make dx subject of the formula, we'll have negative du over 5, and then the hyperbolic function there. When we perform our substitution now, where we have sec to the power 4, we end up with u to the power 4. And then this will remain, but of course it's going to cancel right in the next step. And then where we have dx, we put what dx is, which is du over 5, this. Here, this part cancels with this. Again, I always point out to say, whenever we're using the substitution, the odd variable always eliminates after you substitute. The negative comes here. Of course, there's a 5 coming out as well. So you have negative 1 over 5, this 5 here. And then now we have u to the power 4 du. And of course, this is a straight away integral. So when we integrate to the 4, add 1 becomes 5. Then divide down there. So this becomes minus u to the power 5 over 25 plus c. Then recall what u is. So this becomes sec to the power 5, 5x over 25 plus c. Okay, so how did you approach this one as well? Let me know how the route that you used. Notice that at this stage, could I have approached it differently? I think I'll stick to this one. It's easy and straightforward. In the next problem, we now want to get the integral of tanish the power 3x dx. Again, the technique I am going to use here is similar to a technique I would have used if this was a regular trig function. So what am I doing there? First thing, I'll split this, isolate one of the tanish expressions. So I'll have this to the power 2x multiplying this dx. At this point, I can use the method I used earlier, but now I want to get what this is. I want to transform this into a such. So I'll use the identity that relates this to this. So what's the relationship? But of course, it relates their squares, of course. So you have to remember the identities. And the identity goes that sec squared x is equal to 1 minus the hyperbolic tan squared x. So when you make the substitution, we see that our integral will now just be, we want to eliminate the tanish square, so we'll make this the subject of the formula. So this becomes 1 minus the sec squared x. And then, so the other side, we still have the tanish x dx. So we'll distribute the tanish x there at this stage, or yeah, we'll distribute. So if I distribute, we now have the tanish x minus, then here we'll have tanish x and then sec squared x dx. So the first one is straightforward, the integral of tanish x dx. The second one, we still need to use another substitution here, sec squared x dx. For the first part, the integral of tanish x there, that will just be ln of cosh x. Now we look at that second part. How do we integrate the second part? So again, here the treatment would be similar to if this was just tan and sec. So you can either, I'll actually choose my u to be equal to tanish x. This way, the derivative with respect to x will be sec squared x. Based on this, it follows that dx will be equals to du over sec squared x. So when we make the substitution, we now have the first part already figured out. And the second part will now be the integral of where we have tanish x, we'll put u there. And then this will remain, but of course, son to cancel out. And where we have du, dx, we'll put du over sec squared x. This and this will cancel, implying that we're only looking at the integral of u with respect to u. And this is going to be u to the power 2 over 2, since we're done, plus c. And when we bring back what u is in this case, when we bring back what this is in this case, since u here was said to be the hyperbolic tan, so this is going to be tanish x. But since u is squared, so we'll square this over 2 plus c. Okay, so this wraps up this session. In the next video, we have a few more questions interesting for us to look at. So we are going to look at these next. So these will require the use of trig substitutions. You see us letting x be equals to a sine theta sometimes. Sometimes we'll say we'll have to complete the square first. Sometimes we'll use hyperbolic substitutions. So depending on what suits the problem. So try them out. Let me know what you find. If you want me to take a look at what you find, send me your solutions using the numbers in the comment section or in the description. Now guys, hope you found this helpful. If you did, let me know in the comment section. Bye.